Today we're looking at Unit 2, Lesson 3, Working with Slopes. So to find the rate of change, which we're talking about today is also called slope of a table, is what you did in the last unit. You do it just the same way. You start with your change of x, and you can use a number line to look at what change is happening here. So to go from -7 to -4, I'm going over 3 spaces. Just to make that clear, you're starting here and you're ending here. So you are increasing 3 because you're going to the right to get to that value. So increasing by 3, -4 plus 3 is -1, and -1 plus 3 is 2. To look at what is happening with the change in y, to find our rate of change, we need both of those values. 5 minus 2, this is going down, so it's a negative change, -2. 3 minus 2 gives me 1, and 1 minus 2 gives me -2. So when I need to find my rate of change or slope, that is the change in y over the change in x. So that's what I'm looking at right there. The rate of change, we often abbreviated that just ROC, or slope, is change in y over the change in x. And in this case, it's going to be -2 over 3, or -2/3. The next part of the question is asking us to plot the points from the table on the graph to the right. So I'm going to plot these points. My first point is -7. And remember, the x's are left and right, and the y values are up or down. To go to -7 horizontally is to go left 7, and then I'm going to go up 5. And that's the point right here. For -4, 3, left 4, up 3. -1, 1 is left 1, up 1. And hopefully you're seeing a pattern as we graph this. 2, -1, our last point here, is to the right 2, down 1. And you can see that those all do lie in a line. So we did this one. How can you find the rate of change or slope when the points are graphed? So what we're asking for is, how do we see it visually over here on the graph? So we can get it from the table, and we do the change in y, and then we divide that by the change in x, and so -2 over 3. Because this is a line, because our change in y and change in x is constant, it means we're going up by the same amount each time, which is what makes our points fall into a line or be in a line. So how can you find the rate of change or slope from the points? You can look at what's happening between points. So for example, I can see that I am going down 2, and I'm going to the right 3, so +3, to find my next point. And that is true as we go between any point. So down 2, right 3, and that pattern continues down. So down 2, right 3 on this other point. So those values are going to stay the same. So to say, how can you find the rate of change or slope when the points are graphed? You can count down 3 and right, oops, that was a lie. We go down 2 and right 3, as shown in our table here, from one point to the next, or we could say between points. So you can see that in your graph in this way. Use the slope to find the next 2 points to the right of 2, -1. So that's this point right here. So if I want to find the next point, we have the point to the left of that. I want to find the next point to the right of that. I can still use what I know about slope and what I know about my change. So I know that I need to go down 2 and right 3, and I end up with this point right here, and that point is 5, -3. And let me slide my page up so you can all see that too. And to find the next point, again, we're going to use that same down. So that's down is negative, down 2, and to the right 3, because right is the positive direction for x, plus 3. I have a point right there, and that point, if I read, is over 8 and down 5. So that would be 8, -5 as an ordered pair. You can see that all of those points, our new points too, are all falling in the same line. We're going to take a look at this next example. I would like you to do this on your own. The first thing we're going to look at is finding the rate of change or slope of the table. And you can recall what we did from the previous example. Just like we start anytime we see a table, is we're going to look at the change in y and the change in x. So pause here and complete this part of the problem. Hopefully you see the same change in x and the change in y as I have on my paper. The y values should look familiar because those are the changes that we had for the x values in the previous example. And just in case you want to review that on the number line, if you start at -7 and you're going to -4, that is an increase of 3 on a number line. That's what you want to think about. You can also think of you have a built-in number line right here on your coordinate plane. So if I'm looking at -7 and I need to go to -4, I can count those spaces over to see that that is an increase of 3. Now write down the rate of change. You can see rate of change is always the change in y over the change in x, and our change in y is 3, our change in x is 1. You can reduce that to 3, but I do like to keep thinking about it in this form of a fraction. 3/1 is equivalent to 3, but when we're plotting points, having the 1 as a placeholder for the change in x is going to be helpful for us. At this time, I'd like you to pause and plot the points from this table. And hopefully you see your points line up where my points line up on the graph. And now we're going to look at how can we use the rate of change or slope when the points are graphed. Again, we want to look at, to read a graph from left to right, just like you read a book, I always start at my furthest point to the left to go to my points on the right. So I'm going to do my change in y. I'm going to go up, and I'm going up 1, 2, 3, just like my table is right here. So I'm going up 3 to get to my next point, and then from there I'm going to go to the right 1, which is also positive 1 value. And you can get to all the points that way. And part D is asking us to predict or to find the next 2 points. So we can use our slope by going up the change in y and over the change in x. So to have that labeled, vertically is your change in y, and horizontally is your change in x. So this is my change in y, and this little bit over here is my change in x. please find the next 2 points. I'm going to pause right here so that you can do that on your own. Hopefully you realize that it's to the right of the point 2, 2, which is our point right here. You are going to continue going in this way, up 3, and to the right 1, that point right there. You can read off of your graph is 3, 5 is the next point. And you're going to do the same process again to get another point. And you could do this indefinitely. You could just keep going until you run off your graph and then some, because lines go forever. So up 3, to the right 1, and that point is right here, and it's 4, 8 is the next point. So your x value increased by 1 and your y value increased by 3. So you can also see that in the points. So your y values from here to here increased by 3, and your x values increased from here to here, which was an increase of 1. So you can see it in the point, you can see it in the graph, and you should see that all of these points lie in a line. Now I'm on the next page, on page 68 in your portfolio, and we're looking at the table that was number 1 on the previous page, which we talked about. The change in x is 3, and the change in y is -2. So from our work with tables, we know that the change for a line is the ratio of the change in y to the change in x, and we can write that as rate of change as a ratio. We often wrote this as the little triangle, which is delta in the Greek alphabet, change in y over the change in x, just so that you see it how we often wrote that in class. And in this case, it was -2/3. We also know that the rate of change for a line is a constant value. No matter which pair that you take on this table, it's going to reduce or be the same as -2/3. Because of this, we refer to the change of a line as its slope, because the slope remains constant, like the slope going down a hill or going down a ladder. We use the variable m to represent the slope. So m equals the change in y over change in x. We call that slope often, but it's the same as the rate of change over the rate of, same as the change in y over the change in x. So looking at this table, this is the graph. Looking at this graph, this is the same information as in the table. We wanted to point out that the change in y is often called the rise of a graph, because it's your vertical change. It's rising, vertical change. And that the change in x is often called the run of a graph, and that's going right or left. And you can, this value is going to always reduce. So we have to reduce our ratio. It's always going to reduce to the same value, because the slope is the same no matter what we are talking about on the graph. This is true no matter which 2 points you pick on the graph. So for example, if I pick this point over here at -4, 3, and I'm looking at the rise over run, or the slope between this point over here at 2, -1, the change in y, or the rise, would be -4 over the run. There's 6 units here. That doesn't match the -2/3 that I have here, but I can reduce this. I could divide -4 by 2, and that gives me -2, and I could divide 6 by 2, and that would give me 3. And we're allowed to cancel common factors out of both of those numbers. And so you should see that it always reduces to the same value. Let's look at these details. So the rise is positive when you go up. So when you're going up on the graph, that is positive. When you go, the rise is negative. So if you're going down, the value is going to be negative. The run is positive when you go to the right, so that's always going to be positive. And if you go to the left, the value is going to be negative. And you want to simplify your ratios by remembering those rules. My last reminder is just positive divided by a positive is a positive, negative divided by negative is a positive, and if they're opposite signs, the result is negative. We're going to do one example together, and then you're going to do the other two on your own to submit, turn in to Schoology. So the first thing you're going to do is plot these points, graph these points that are given. So -1, -2 is left 1, down 2. The next point is 0, -1. So we don't change right or left, we just go down 1, and 1, 0. So these are all tightly packed together. And they want to determine what the fourth and fifth point is. So we're going to continue going to the right. And what's happening in our table, in our graph, we are going up 1, over 1, up 1, right 1. So the next one would be up 1 to the right 1, and up 1 to the right 1 to find our other points. Those would all fall in line there. So our additional point would be, this point right here is over 2 and up 1. And this point is 3, 2. And our method for finding the point, for what I did was I counted the change in y and the change in x, or you could think of that as rise and run. So I went up 1 and right 1 for this. And for all of these problems, and this was announced in class, but for some of you who missed class and are watching this, for every single one of these, you are going to find and tell me what the slope is. So for this example, the slope is change in the rise, or the change in y, which is +1, it's going up, and to the right 1, which is also positive. So you can reduce that to 1 if you want, but it is a change in y over change in x is 1 over 1. So for homework today, you're finishing this page, you're submitting it to Schoology, and remember, for each of these other problems, you are going to tell me the slope on 2 and 3. So you're doing these on your own, calculating the slope. Thanks.